So I'm going to open up our lesson 6 file. I'm going to minimize this so it gets all that tied down. I wish it would just start this way. I go to my T drive and my lesson 6 folder and open up my lesson 6. I know I showed this to you the other day, and I don't remember if I showed the whole class, but when you can't read the name, if you just kind of highlight the little line right here between file and size, you can drag that over. That way you can see the whole file name. I'm going to load that in. And then after I load that in, I'm going to go to the input screen. Import export functions. Import NC state from file. And I'm going to bring in the NC state as well for that same file. Bring in all this information, hit begin. Should say imported successfully. And now if I hit play on my draw screen, change my view up, I should see that part with the stock setup and everything just like we had the other day. Little fun fact, remember the other day I was trying to show you that jump function and mine wouldn't work but all of yours were? Was that in this class or was that the other class? Must have been the other class. So the other day I couldn't get mine to jump to the line of code showing you where you hit select here and you click on the line of code. This one's not wanting to do it now. Of course we're back into a day where it's not going to work. But yours should let you pick on where you can pick the line and then hit jump right here. It'll jump to that line of code in the program. So if you have an issue, you can see where it's at. The other day mine wasn't working, but yesterday it started working for me. Today it's not working again. I don't know what's going on. We'll see if it works in this next program we do. Okay. Everybody's drawing okay? All came back in just like we left it off? Okay, so we're going to open up our books to Lesson 6, Part 5. Lesson 6, Part 5, which is this part right here. Okay, so if you go ahead and open up your books and get on that page. Got your book? Okay. So, if you want to double check your answers, there's the points, which this one should be pretty cut and dry. Shouldn't be any problems there. Okay. We're going to program this little L slot. So let's go to our programmer and let's start out by going to Program Manager. Let's do a save as, and then let's change the file name from Lesson 6 Exercise 1 to Lesson 6 Part 5. And we'll hit save. Now that's our active file there. Okay. Little interesting fact. So I don't know how the classes got alternated up, but I don't know if any of you know Jacob Cummins and Isaac Hell that are they're in the after the morning class, afternoon machining class now. They were in 122 last semester. Their high school instructor sends me a picture this morning, said they either missed me or they wanted to see if their programs actually worked, and they're at her shop right now running the program that we wrote in class together just to see if it actually worked. So I thought that was kind of neat. They actually went and ran it. We will do that. You're all going to get a cut. The last part we do together with cutter comp and everything, we're going to go out to the machine and we're going to run it. We're going to make the little plate with the pocket and all the stuff that we do. I'm going to show you how to use the conversational side and engrave your name on it, so you get to do that too. But that was kind of interesting to me that they were at her shop this morning on the Herco that used to be in this shop that Princeton High School bought, that they've got down there now. So, all right, let's double click on this. And I guess the first thing I'm going to do, because we modified the stock setup a little bit, so let's go fix that first and let's save that to the NC state. So all we have to do is go to part setup up here. just remember to get to the stock setup, you go to part setup, hit more, stock geometry. And the only thing we got to do is we're going to change it back. Instead of 3 1/4, let's make it 3 inches by 3 inches by 1/4 inch Z. The reference position, 0, 0, 0, because it's that front top left corner. And that's where it is by default, so we don't have to move the reference location at all. Okay, everybody good? Now to save that change that we just made, we're going to jump back over to Program Manager and hit save. And what that will do is, by default, it's automatically updating the NC state too. We didn't change the program any, but it's going to fix that in the NC state. So when you load the NC state for this file, the stock setup's correct. You don't have to go in and modify it. All right, now we can go to part programming. Okay, and today is going to be class participation day. So I'm going to go around the classroom. Okay, and I'm basically going to go line by line and ask you, hey, do we need to change anything? Yes or no? And if so, what do you think we need to change? All right, until we get to the points. Okay, so Reagan, what are we going to change our program number to?
3065.
605. Lesson 6, part 5. Come up with a system. You know, in here, this is our system. When you're in industry, we're not just picking numbers out of the air. We need a good system. When I'm in industry, everything I do, because I do a lot of stuff for different shops, so when they all know how I number the programs. It's the date. So mine, like today, would be 291. So second month, it'd be 2091 if it was the first program I did that day. Some shops I go into and I write 3 or 4 programs, so they would have 2091, 2092, 209, and I do it by the date. Now, if I go back into that same shop next year, a year from now, on the same exact day, I'm going to look in their programs, and if I've already got 1, 2, 3, and 4 in there, I'll just pick up 2095, 209. Does that make sense? That's how I number programs out in shops, unless they say use the serial number. If they don't have a standard way of doing it, I just implement my way. Okay, so just keep that in mind. All right, Jack, how about up here?
The
Exercise. We're going to change that to part 5. Pretty simple. Okay. Mr. Mueller, how about safety line? How you feel about it? Looks good to me too. We don't change the safety line. It sticks. It stays where it's at. All right, Blaine, how about the origin position? Same. It's still the XY front left corner of the part. No changes there. We'll just let the Z go wide too. All right, Spencer, how about the tool? What tool is it using in this program? Tool number 4. Same tool. Okay. We're coming down here. Isaac, how about our tool change line? How's it look to you?
Good.
Looks good, doesn't it? I know Captain Obvious is standing up here right now, okay? But what I'm showing to you is that we can work really smart by utilizing the stuff that we've got in our database, okay? 9 out of 10 programs I write in Mastercam even, I open up another program and start with that other program. Okay, if I've got a program, especially for some of the shops I work for that I do the same kind of stuff, just maybe different hole locations, different pattern, or a different milled slot with the same tools, I'm opening up a program where I've used it, creating the new geometry, reselecting the geometry, and refresh. Okay, so it's very rare for me to start from scratch at this point. It's very rare. Okay. All right, we're verifying the tool. Aaron, how about our start location here?
Looks pretty good.
It does, maybe. Curveball. Let's start at location 1. We're going to go to location where the first cut location is. So give me the X and Y for point 1.
X 0.750 and Y is 2.5.
2.25 or 2.5? 2.5. Okay. All right, I like that. I'm even going to say P1 here. Okay. Fulkerson, how about our G43 line? Anything need to change there?
Looks good.
Looks good. We're coming down to 2 inches above. We're going to do an op stop. We're good there. Noah, how do you feel about our spindle speed? We're going to leave it the same. It's turning on 7639 clockwise, M3. I didn't look today, but yesterday I caught a couple people that put G's on codes that they had the right number, but they put a G instead of an M. Remember, if it's a machine function, you're turning something on and off. Turning on the spindle, shutting off the spindle, turning on the coolant, shutting off the coolant, resetting the program, stopping the program, program stop. It's going to be an M code. Okay, if it's something that's physically happening in the machine, it's an M code. If it's a movement type, line, rapid, curve, clockwise, counterclockwise, can cycle, if it's a movement type, it's a G code, preparatory code. Okay, you're basically saying, hey, all right, in this line, you're going to do a straight line move. In this line, you're going to do a rapid move to this absolute value, work offset 1 to x.75, y.2.5. Okay? All right. Right here, where are we at? I want to come down to the very top of the part. So what would my Z be if I want to come right to the top of the part? Right to the top of the part. 0. I like it. Okay. 0. We're going to come down to Z0. I don't need this to say initial height. I'm going to say drop to top of the part. Now, the other day we did something that I kind of talked about being a bad practice. I don't like plunging, straight plunging. If I'm going to straight plunge to depth, I want a pilot hole there typically. I like to do either a ramp or a helix entry to take less. When you straight plunge, even if it's center cutting end mill, there's nowhere for those chips to go. They get balled up down there underneath the end mill, and it's going to chip your end mill up. You get away with it a couple times in aluminum, plastics, things like that. You can get away with it, because they're soft metals that aren't very aggressive. When you're cutting different types of steel, especially tool steels, alloy steels, pre-hard steels, a straight plunge is just a big no-no. You're going to work hard in that material, and you're going to end up losing your end mill, and then the piece of material is probably not going to be any good either, because you got to work that out of it. So we're going to come to the top of the part here. What I'd like you to do is put your cursor right here in front of this plunge to depth line and hold shift and go ahead and select all of the absolute moves we did on that last part and delete them. And then put your cursor in front of the incremental moves, hold shift and select all of them down to, there we go, back live. Down to right here where we went back to the origin, and let's delete those out. So basically we got our Z0 to the top of the part with our coolant command, turning coolant on. We don't have any movements, and then we have our Z2 going back up and shutting coolant off. All right. Isaiah, I want to go to 0.2 here. And I want to go down a 1/16 of an inch of the 1/8 inch deep total we want to go. So give me my move first, my X or Y. Give me that first. Y 0.75. And then I'm going to ramp halfway to depth going down to 0.2. So I'm going to do a Z minus 0.0625. The overall depth's an 1/8 inch. I'm going to do it progressively as we make this little L channel here. So that gets me to P2. And then Brandon, give me my move to P3. 2.375. And we're going to go on down the extra 1/8 inch, or down to an 1/8 inch. We're doing it absolute though. So it's not another 1/16, it's literally Z minus 0.125. Let's go ahead and draw that. And there you can see what we did. We started up here, we ramped halfway to depth, and then we ramped the rest of the way to depth here. Okay, if I go to like this view, you can see it. If I go to the side view, you can see where we started out here, coming down to 16th deep, and then got the rest of the way. Sometimes if you're, how I can see through my part, I have my opaque right here shut off so it's translucent so I can see through it. It's not gonna work today. I don't know why my jump function won't work. Usually it does, but today it's not. Monday it wasn't. Yesterday it was. Yo.
My graphics are not wanting to turn on.
Okay. Give me 1 second. If yours looks good, I'd go and hit save. That way it's out. Go back to it. Okay. So the same thing we had to have the other day. Go back to your program. Your G43 line. Well, you got your C1 or your G1 right now.
It's not. I know.
Hit play over there.
It's not.
reverse. Not literally, we're not turning the spindle on in reverse, so I don't want to get you confused there. We're just going to go back while we're at depth, and I want to go back to 0.2 at depth. Okay? Rachel, give me 0.2. What's the value for 0.2? X 0.75. Y 0.75, which we're already at 0.75y, so we can just put the X there. We're going to go back to 0.2 at depth. Shedderly, give me 0.1. We're going to go back to 0.1 at depth.
X 0.75, Y 2.5.
Y 2 point, is it 2.5? Yep. See, I don't know my points. Okay, we're going back to 0.1 at depth. So we're milling a slot. Now I will tell you this, and you've probably been taught this back there, and you're going to get taught it out here. It is very rare that you're going to mill something the size of the tool that you're cutting it with, meaning it's not a great machining practice to make a 1/2 inch slot with a 1/2 inch tool. Now, if it's just like a clearance slot or something, yeah, just slot it out. But typically, we're not working on Grandpa's farm. Okay? Typically, we're not working on Grandpa's farm. Typically, we're trying to hit some dimensions that are a little more critical. And if this tool's wore out at all, we don't have any way to try to adjust the width of that slot without cutting it once, then going in and adjusting like our X values and our Y values to try to make it wider. We definitely can't make it any smaller than the tool. All right. So we draw that now. You should see it's went back through and cleaned out the bottom of the slot. Looks good, doesn't it? All right. After we get everything milled, Reagan, how do you feel about this Z2 M9 right here? You like it?
Yeah.
I do too. We're just going back up to 2 inches above and shutting off the coolant. Jack, you feel good about the G28, G91, Z0, M5? Yep. Nope. It's going to the Z reference. It's going to the reference position in Z incrementally from wherever it's at in Z. Okay? Wherever it's at in Z. So it could be way down here. It could be right here. It's going back to the machine home position, which I showed you the other day is set up in the controls. It's a parameter that's set up, configuration parameters, right here. We would have that here. Now I will tell you this, the Z home position at the machine is whatever the calibrated tool height is. That's where we have them all set at. Now the X and the Y reference locations typically is wherever I want that thing to stop at the end of the program. Do I want it table right in front and center? Is my vise right there? Is my vise over here? Is my rotary being used? Do I want it to go further left? I can change that number, and then it will use the same code to then position the table for the operator to be able to change out parts. Okay? All right, so we're good there. Mueller, how you feel about the next line? You like it?
That's fine.
Man, you got 2 easy ones. Prosser, how you feel about the M30 line? I like it too. Program end reset. We got our % sign down here. I'm going to hit save. Okay. All right. I'm going to open something up here. Okay. When we post out a Mastercam, this is the Simco code editor. There's a link on your desktop. You don't need to open it. This is the Simco code editor. When you post your program out of Mastercam, it sends it to this code editor. And when you open them, I'm going to open up the last one we posted out, which was the project that we're working on the 2nd year. This is coming from Mastercam. Okay. There's what it looks like after we post it out to Mastercam. This is what we take to the machine. Looks pretty familiar. It should. You know. We got a program number up there. Now we just left the program number 0 for this. We got our program name. We got the machine group that it comes from, what the part name is, who posted it. So it came from IC to Mastercam. February 6, 2023 at 1:38 p.m. we posted it out. We're using tool 3. That's the only tool we're using. There's the tool information. We got our safety line. We've got a G91, G28, Z0 at the beginning of all of our programs. I had that added to our Mastercam post because I got tired of students breaking tools because they were setting them off their tool setter down here and on the right side of the vise, and then their start point was over here with the part that's in the vise, and they'd hit go, and the machine tried to go rapid from there to the start position, and it didn't know it needed to come up and move over. Rapid tries to go in a straight line. So it just kind of think about that. That's basically what would happen. Tool gone, vise has a big notch in it. Or the part has a big notch in it, depending on where you're at. So I had that added to our post processor. I said, hey, I want a safety line with the safety line that basically tells it, hey, I don't care where you're at in Z at the beginning of the program too, I want you to go to Z home before you start. All right, so that's something, that's a VU thing. Tool change. There it is, T3 M6. Now you see these N numbers. Those are in the book. It talks about them. They're called sequence numbers. Some of you may have in high school when you programmed or before when you programmed, you might have put sequence numbers at the start of every line. You don't have to have them. I don't put them in. As a matter of fact, our Mastercam programs, we don't post them out with every line. Even that one, we don't have to put them in. The only sequence numbers I want is at like each tool. So when I use the first tool, there's an N1. And what that lets me do is if I know I want to go start at my first tool, I can search N1 and it will find that line of code. And I can set my start marker there, my restart or my start marker. So you won't see a lot of sequence numbers in my mill programs, but they don't do anything other than help you identify the lines of code. This is what Mastercam pumps out for all these little arc moves. Okay, you can understand why some of these more complex shapes and parts, it's kind of valuable to have a cam system. Okay, there's 1,355 lines in this program. All this program's doing is cutting one pocket, the shape of the knuckle on the sweeping arm. Okay, it's cutting a pocket that is the shape of this piece right here. That's all it's doing, this little piece. But the thing about the cam system is you can tighten your filters up to where it makes really, really small linear moves to be more accurate. And honestly, if I don't have a machine that's got memory issues, meaning that it's not 20, 30 years old, I don't really care how many lines it has, because most of them can process that code so fast you don't even know what's going on. You're not going to go in here and do all this math with the calculator in your head. Okay, you got to have a cam system for this kind of stuff. But I'm going to jump to the end of the program when it gets done, and you're going to notice down here at the bottom, looks pretty familiar, doesn't it? It's pretty similar to what our structure is. 2 inches above, shut off coolant, shut off the spindle, G28Z0, G28X0Y0. The G91 is modal, so you don't have to have it in both lines. I know I have it on the header sheet that way. You don't have to have it in both lines, but I still do it. Then it automatically in Mastercam, I've told it I want it to switch itself back to main or absolute before program ends resets, so it doesn't leave it in incremental. Okay, so G code is G code. We're learning how to write some manually. All we're going to do when we get to the cam system is basically make it easier on us. Less math for us to do as long as we can draw the part correctly. We learn how to apply the tool paths. It'll take care of the coding for us. Okay. All right. Okay, let's open up lesson 6, part 6. I'm going to program one more together. So let's start out with lesson 6, part 5. Let's do a save as. Change it to lesson 6, part 6. Hit save. go into it. Let's start at the top. I'll start at the back of the room this time. Shedley, what's the first thing I'm going to change?
The name. So you're gonna have a 606 and less than 6 part 6.
Lesson 6, part 6. Rachel, how do you feel about the safety line? Do you like it? I do too. I do too. Safety line never changes. It's going to stay the same. All right. Faith, how about the origin for this part? We're good. Same spot. Klinger, how about the tool? We're good there. Jackson, how about the tool change? We're good there. Things looking pretty hot right now, isn't it? All right. Come on down. We'll come down to the G90 line. Noah, how do you feel about it? We're going to change our X and Y. We're going to go to position 1 on the chart. So same thing there. We're going to start, and this is how I kind of try to do this. I got a little too technical with it yesterday because I was like, I like to start the radius off the part plus the radius of the tool. And then I said, well, let's just not get it too technical. Let's just say the diameter of the tool, because 2 radius is going to be the diameter of the tool. So we're going to start negative a ½ inch off in X, negative 0.5 in X, and then Y, the Y value comes from, we're starting where we can mill straight from here across this top ledge here. So I'm going to do the math up here on the calculator for a lot of these as we work through them, just so you can see the math. So the first thing I'm going to do is, I got my 0.25 down here. So 0.25 plus 2.625 right here, plus the tool radius. So we're starting at Y 3.125. Okay. How's that happen? Fulkerson, how do you feel about the G43 line?
Looks good to me.
Looks good to you still, doesn't it? Same line. Somehow the same person gets the same line. All right. We're coming down to 2 inches above. We're hitting the brakes with an op stop. Checking it out. Making sure it looks good. Aaron, you okay with coming down to the top of the part there, or what do you think? Plunging off the part. What do you think? We could go to above the part, or we can go to depth. We're over here. Let's just go ahead to depth. So we're going to cut 125 thou deep. So we're going to do negative 0.125. Plunge to depth. Oh. Okay. Sorry. All right. Let's get rid of these points here. We're at depth. We're ready to start making our way around the part. So I'm going to start up here with Isaac. Get me over to 0.2. What's my move?
X 1.375.
1.375x. The Y doesn't change, does it? So that's 0.2. Okay. We're going to go 2 points at a time, then we're going to draw it and look at it. I'm going to jump over and do the math as well. So I'm going to come over here, and this math came from, we've got 0.375 from here to here, plus 3/4 of an inch here, plus the tool radius, 1.375x. All right. Spencer, how about my move down to 0.3? y 1.75. 0.3. I'm going to go ahead and draw that. And I'm going to go to my top view just so you guys can see it straight over the top. Mills across here, mills straight down. Looking good so far. Look at that. It's going to let me jump to the lines now all of a sudden. How about that? All of a sudden, it's going to let me actually jump to the lines. Okay. We're good so far. All right. Next move. Prosser, get me to 0.4.
X 1.5.
X 1.5. Little bitty line move going over to 0.4. Okay. Mueller, how about up to 0.5?
X is the same. Y is 3.125.
3.125. Okay. So I'm going to do the math on those two for you. Okay, let's do the math on them. To get from 0.4 from here to here, basically, we know we've got, and I'm going to do the math all the way across. I'm not just looking at it visually and making a judgment. We don't do that. We never judge off what it visually looks like anywhere. We use the dimensions on the print. Okay, so I know I've got 0.375. That's from here to here, from the origin to here, and then 0.75 from here to here, plus 0.75, plus the width of the slot is 0.625, minus my radius. So there's where our 1.5 came from. And then we've got the same math here. We've got 0.25 plus 2.625 plus our tool radius 3.125 for our next y for 0.5. Okay, so we're looking good. We should be able to draw that and see that right there. All right. Next move, Jack Briggs, give me the 0.6.
You move the X to 2.875, and then the Y is 3.125.
Yeah, Y doesn't change, so we just got to do an X move. And you don't have your book, so I'm not gonna put it on you there. But let's do the math together, all right? So we're going to 0.7. We're coming down to right here. So the math to get to 0.7 is going to be the 0.25 from the origin up to the edge here. So 0.25 plus 1.25 up to this edge here, plus the tool radius. So we're going down to y 1.75. Okay, we draw that now. Looking pretty good. Everybody's looking all right to that point? Okay. All right. Jump back to the back of the room. Rachel, can you get me over to 0.8? What do you have for 0.8?
X 3.125, Y 1.75.
Y 1.75, so the Y didn't change, so we'll just put our X there. Alex Shetterly, can you get me to 0.9?
9. Y 0.
Y 0. 0.9. And I like 0.9 because that's one that really is tough and I want to visually look at it and be like, oh yeah. But you got to do the math. It's pretty simple. This edge is at 0.25 minus the tool radius, 0.25, 0. Okay, simple stuff there. All right. And Fulkerson get me to 0.10.
So the X is just an 8, like 0.125.
X.125. The edge of the parts 0.375 over minus the tool radius 0.125. Okay. Now this last point here, Noah.
Yeah.
I want to go up to the top of the part plus the tool diameter. So basically it'll get us a 1/4 inch off the part. So what would you say my Y value should be for that, for the Y? 3.5. Yeah, 3.5. Because so I know what this says in here on my answer key, and if you saw that, or if you followed along with the book and you checked your answers, it probably gave you that. And that's what I wanted to talk about when I said whatever I start and end off the part, the diameter of the tool. So I know for some reason they started off the part a 1/4 inch and then they ended off the part an 1/8 inch. Just keep it consistent, do the same thing, make it the diameter of the tool off the part. That way you'll have at least the distance of the radius out of the cut. Okay, just make it the same. You're right for what they had on the thing. Okay, so I'm gonna call that 0.11. Contour finished. If you watch it and verify and it looks good, mine looks pretty good, and you like it, better go hit save. It's pretty windy outside. I'd hate for the power to go out. Okay, hit save. All right. It is 1:34. Your assignment for next Tuesday, and you've got the rest of the time, and I would strongly encourage you to stay in here and work on these and go ahead and get them done. Don't try to have to do it later or think you're going to make time. If you're pretty responsible about doing it, do it, but your assignment is programs 7 and 8 to be complete and ready for me to look at the start of class on Tuesday. Okay, programs 7 and 8. You should be able to do a save as with this one. Change the things we just changed. Change your X and Y's for the profile of the part. Save. Save as for part 8. Change the positions. Change the stuff at the top of the program. Program number, comments. There's no real curveballs here. Okay? That's your assignment to have done for next Tuesday. And you've got the rest of the time to work on it. I am done up here preaching at you. Okay? All right. You want to go grab your book?
Yeah.
Good man. I'll be right there. One sec, Rachel.